Alright, so these are approximation methods, so they take us close to where we want to go, and theoretically by increasing the number of strips, the number of slices, we can make them as accurate as we want. But how good are these? Well, it turns out that mathematicians have asked this question. There is a whole branch of mathematics that actually deals with assessing how good certain approximation methods work. And those mathematicians who have looked into this question have come up with something reasonably simple to analyze in the case of the midpoint, trapezoid, and Simpson's rule. And the idea is the following. Let's say that we're dealing with a function that is twice differentiable. Remember, this is requiring more than we require to establish the existence of the integral. All we need for that one is that the function be continuous. So, if we require a little bit more, and if we accept the fact that the function is actually differentiable twice, and assuming that k is the maximum of the second derivative between a and b, then it turns out that the maximum possible error for each method can be estimated, and it looks like this. For the midpoint formula, the difference between the midpoint approximation and the actual value of the integral in absolute values of the actual error is going to be less than or equal to that weird looking expression. Okay, it's not that I don't want to read it, it's not very bad, but I agree with you that it's kind of scary, and I do not expect you to memorize that formula. I'm just going to analyze it briefly with you, just to compare the three methods. For the trapezoidal rule, the same formula, the best that we can say is that the difference between the trapezoidal approximation and the actual true value of the integral is no more than this other formula. And for Simpson's rule, is the difference, the possible error, is no more than this formula. Now, those formula really, you look at them and say, oh, nice, what can I do with them? Well, let's see what we can do with them. Compare the midpoint and the trapezoidal formula. They look pretty much the same except for the denominator. The midpoint formula this maximum error is some formula divided by 24. For the trapezoid is the same formula but only divided by 12, which means that the trapezoidal approximation may end up being bigger, in fact twice as much as big as the midpoint formula. By the way, I want to clarify one thing to avoid giving you the wrong impression. The numbers you see, or those expressions you see on the right hand side, they do not tell you that that is what the error is. They tell you that the error cannot be any greater than that. So in other words, we're not saying that we're definitely going to run into that kind of error. It only tells us that we're not going to run into any error larger than that. In particular, what that means is that in some special cases, the trapezoidal rule may in fact end up being better than the midpoint rule, although quite frankly I have not seen a simple enough and useful enough example of that. But again, that's just a clarification that needs to be done. But if you just compare the formula for the midpoint and the trapezoid, you can see why the midpoint formula is better. And again, that's justified by the fact that the midpoint does a little bit of balancing, the trapezoid doesn't. On the other hand, look at the formula for Simpson's rule. Yes, the top is b minus a to the fifth power. So if that b minus a is a large number, that fifth power actually could be a much bigger number than the b minus a cubed we have in the other two formula. However, look at the denominator. Not only we have a 180 by n, but n is raised to the fourth power, which means that Simpson's rule uses the slices much more efficiently, right? By choosing just a few more slices, we get a much bigger improvement in the approximation. And then of course 180 is way bigger than 12 and 24, so it's going to usually balance the problem with the b minus a being raised to the fifth power. So these three formula, again, I don't expect you to memorize them, but these are bounds which tell you a little bit of the story. The midpoint formula is a very nice formula, very good, easy to implement and everything. Trapezoid looks like an improvement, but it is not. In fact, trapezoidal formula is something that you should not, I would not recommend that you do. I may ask you to do it in a test just to make sure that that you know how to do it, but in practice it should not really be used. Simpson's formula, on the other hand, that should be our favorite one and should be the one that we're going to use most of the times if we have to.